Hello students, welcome for MD2 lecture. In today's lecture, we will discuss how we can design two-stage spur gearbox. Okay, I will just share my screen. Okay, you can look at here in a two-stage gearbox. We are using three spindle, two stages, and four different gears. Okay, I have mentioned over here N1, N2, N3 and N4 are the four gears which are we using, that is speed N1, N2, N3 and 4 of gear 1, 2, 3, 4. Now here N1, or you can say gear number 1 is pinion, gear number 2 is gear, 3 pinion, 4 gear. So small big, like that. Now here we have mentioned we are using in we are designing this gearbox in two stages. Let's see how, by taking a simple example. The design of two-stage spur gear reduction unit with a 20-degree full depth involute teeth. The input shaft is connected to the 9 kilowatt power with 1400 rpm motor through a flexible coupling. The output shaft speed shall be approximately 200 rpm. The gear are made up of plain carbon steel. Now what we need to find out? Find the dynamic load and check it for wear load. Decide the construction details of gear and pinion showing in a neat sketch. Okay, so they have instructed you. In question, they have specially informed us we need to design based on the dynamic load and check it for wear load. Also, they have tell us we need to draw a diagram where the gear and pinion should be showing properly. Now, first step, we need to write down a given data. That is, the pressure angle is given 20 degree. Tooth profile is involute. Power is 9.5 kilowatt. Input speed 1400 rpm. Output speed is 200 rpm. Now, number of transmission stages. That is, we are planning for two. Okay, so that's why we written number of transmission stages are two. Then material plain carbon steel which is given. So first of all, draw this layout. Okay, whenever you are going to design the multiple gearbox, multi-stage gearbox or single stage gearbox, you need to draw this such type of layout. Then we need to find out the total transmission ratio, input to output. Okay, that is called as a speed ratio. Yeah, I have denoted the actual speed ratio with I dash. Previously also we have denoted it with I dash. So 1400 divided by 200 is equal to 2. That is the angular velocity of driving gear divided by angular velocity of driven gear. That is called as a pinion, you can say. So we get value of I dash is equal to 7. Now we need to find out the gear ratio for each stage, as we are deciding to manufacture this gearbox for two stage. So I is equal to root of n, मतलब nth root divided by into bracket I dash. Okay, तो मतलब क्या है, हमें I dash का nth root find out करना है, where n is nothing but the number of stages. Okay, तो आपको अगर टू स्टेज में करना है, you need to find out square root of I dash. Okay, so it's nothing but square root of 7. What do you get? I is equal to 2.645. तो each stage में आपका transmission ratio रहेगा 2.645. Now here, for easy manufacturing process, 1 and 3 and 2 and 4, these gears and pinions are we can making identical. तो ये सेम ही रहेंगे. जब मैं नंबर 1 पिनियन को डिजाइन करूंगा तो वो सिमिलर 3 वाला रहेगा. 1 and 3 के डायमेंशन सेम रहेंगे. And similarly, when we are designed for gear number 2, then it is identical with gear number 4. तो इसका मतलब है 2 और 4 के जो डायमेंशन रहेंगे गियर के वो सेम रहेंगे. Now next one, we need to identify minimum number of teeth on pinion to avoid the interference. तो हम लोग क्या करने वाले हैं, दो स्टेज में पहले पेयर को डिजाइन करेंगे, वही पेयर हम लोग दूसरी स्टेज में भी यूज करने वाले हैं. तो यहाँ पे आप सेम आइडेंटिकल गियर्स और पिनियंस यूज करो so that your design will be easier. Okay, otherwise if you are changing the type of gear also, you need to redesign it. Now as per our experience, minimum number of teeth required on pinion, which we have already once calculated, that z1 is equal to 17. As the transmission ratio is 2.645, okay, we can find out the number of minimum number of teeth on gear, that is a z2, that we can calculate is 44.9, approximate 45. Now exact transmission ratio you can find out, okay, because when the same material used for pinion and gear, the pinion is always weaker than the gear. Okay, so z1 and z3 is equal to 17 and z2 and z4 is equal to 45. So the n1 is equal to 1400, then n2 we can find out from empirical relation, n1 n2 is equal to z2 divided by z1. empirical ऐसा है n1 z1 is equal to n2 z2, तो उसको हमने bifurcate किया, n2 divided by n1 n1 divided by n2 is equal to z2 divided by z1. We know the value of n1, z2, z1. Now we can able to calculate value of n2. Now putting all the values, what we get, n2 is equal to 528.88 rpm. So n2 is connected with n3. Now you look at here, n1 input speed, n4 output speed. Okay, ये अलग दो शाफ्ट हो गए, ये शाफ्ट इनपुट का हो गया, ये आउटपुट का हो गया. नाउ बीच में से, नाउ बीच में जो शाफ्ट है उसका हमें स्पीड जानना था, तो हमने एम्पिरिकल रिलेशन यूज किया जिससे हमने n2 फाइंड आउट किया. n2 और n3 का स्पीड दोनों का ही एज दे आर लाइंग ऑन सेम शाफ्ट, तो इनका स्पीड भी सेम रहेगा. सो n2 इज इक्वल टू n3 और उसका स्पीड है 528.88 rpm. Okay, now you can check whether the n4 is nearer to that or not. Okay, तो हम लोग क्या करेंगे, n4 जो है वो आउटपुट 200 rpm is required, but as we know that the transmission ratio get changed due to the number of we have calculated value of z2 is 44 point, but we are considering it's a 45 because half to तो हम नहीं ले सकते, तो उसकी वजह से ट्रांसमिशन, दैट इज अ मॉडिफाइड ट्रांसमिशन रेशो जो हमें यहाँ पे यूज करना है, उससे एग्जैक्टली हमें पता चलेगा कि कितना आरपीएम हम लोग ट्रांसफर कर रहे हैं. सो आप n4 को कैलकुलेट कर सकते हो बेस्ड ऑन द एम्पिरिकल रिलेशन. n3 z3 is equal to n4 z4. Okay, putting all the values, what we get, n4 is equal to 199.79. Okay, it's equal to 200 rpm, so whatever we are designing, that is acceptable. From this speed comparison, it shows that the second stage transmit more torque than the first stage. How? Because the speed drop is occurred in second stage, तो यहाँ पे टॉर्क ज्यादा ट्रांसमिशन करना पड़ेगा. फर्स्ट स्टेज में आपका स्पीड ज्यादा है, स्पीड ज्यादा होता है तो लो टॉर्क हो रहता है, और यहाँ पे स्पीड कम हुआ मतलब अभी टॉर्क बढ़ गया, तो हमें डिजाइन करते वक्त फर्स्ट स्टेज वाले गियर नहीं डिजाइन करने हैं, सेकेंड स्टेज वाले गियर डिजाइन करने हैं, बिकॉज इट transmit more torque. Okay, so the pair used for design is M3 and N4, that is 528.88 and 200 rpm. Now find out the material. From PhD page number 8.5, the value of I is lesser than 4, and up to the model 6, we can consider plain carbon steel, that is C45. Sigma B of that is 1400 kgf per centimeter square, and the value of sigma C is equal to 5000 kgf per centimeter square. Next one, we need to calculate the module. Okay, अभी मॉड्यूल कैलकुलेट करना है तो बेसिकली गो फॉर टेबल नंबर 8, PAG page number 8.13a. The calculation of module is based on the beam strength. As we are using spur gear, तो टेबल में नंबर 8 में से आप properly equation ये वाला use करो. M is greater than equals to 1.26 cube root of design MT divided by YP Young's modulus, sorry, Levis form factor YP, sigma P design bending stress, psi M ratio of B by M, and Z1 the number of teeth on pinion. Now the few things are unknown. Now we will calculate these things by one. As we have power in kilowatt, so we have to convert it into the Newton or kg centimeter. Okay, so for that, referring page number 8.55, there MT is equal to 71620. Okay, this equation we can appear, we have to use this equation. तो उसके लिए हमें पहले डिजाइन लोड देना पड़ेगा, डिजाइन पावर देनी पड़ेगी. सो डिजाइन पावर इज इक्वल टू सर्विस फैक्टर इनटू द गिवन पावर. यहाँ पे गिवन पावर कितना है 9.5 किलोवाट. ओके, मल्टीप्लाइड बाय 1.2 सर्विस फैक्टर, तो हमारा डिजाइन पावर बनता है 11.4 किलोवाट. ओके, now put that value of 11 kilowatt and the speed of that at that time. So MT is equal to 97,420 multiplied by 11.4 divided by 200. That is the output speed. Okay, तो उसको हमें डिजाइन करना, इससे हमें क्या मिलेगा, डिजाइन टॉर्क मिल जाएगा, नॉर्मल टॉर्क मिल जाएगा. तो MT is equal to 5552.94 kgf centimeter. Now using similar unsymmetric and overhanging skin, KDK is equal to 1.5. Design torque is equal to calculated torque multiplied by KDK. That is, we can find out the design torque is equal to 8329.41 kgf centimeter. Next one, psi M, that is the ratio of B by M. Table number 12, PhD page number 8.14. You can refer it. As a general ratio is given as a 10. We are considering same psi M is equal to 10. Now we need to find out the Levis form factor. Levis form factor calculated based on PhD page number 8.50. Y is equal to 0.154 minus 0.912 divided by Z1. This equation appears when equation of Levis form factor is for 20-degree involute to the profile. Okay, so putting value of Z1, what we get, Young's modulus for minion is 0.1 0.003. Now Levis form factor based on pitch diameter, we can find out Levis form factor in two manner. Okay, that is the second one. Yp is equal to y into pi. That is Yp is equal to 0.315. Referring PhD page number 8.50. Now putting all the values into the equation, what we get? M is equal to 0.605 centimeter. Okay, so M कितना आया? 6 m, near about 6 mm. Now we have to find out the next recommended value from table number 1, PhD page number 8.2. Here we are referring choice number 2 series, and the value of M is equal to 7 mm. यहाँ पे हम लोगों ने मॉड्यूल अभी तक फाइंड आउट किया है. Now next we need to check it for surface strength, or you can say contact compressive stresses. Referring page number 8.13, table number 8, equation, we know that we have seen. Okay, so sigma c is equal to 0.74 I plus minus 1 divided by a square root of I plus minus 1 divided by I into b into e into mt, design mt. Okay, this induced sigma c value should be less than the design sigma c value. Okay, you can refer PSG. Okay, now unknown things we need to calculate. I, we know that. B, also we have empirical relation of psi. E, we can find out. So let's start with the A. A is the nothing but center distance. A is equal to m z1 plus z2 divided by 2, that is 7 multiplied by 17 plus 45 divided by 2. What do we get? A is equal to 21.7 centimeter. Okay, psi m, b by m is equal to 10, m is equal to 7, so b is equal to 70 mm, and b is equal to 7 centimeter. As we are using steel material, E is equal to 2.15 into 10 to 6 kg per cm square. From table number 9, PSG 8.14. As we are using external gears, the positive sign will be considered, plus sign will be considered. So sigma c, now putting all the values of things, what do we get? Sigma c is equal to 7380.44, and our design value is 5000 kg per centimeter square. It means that मॉड्यूल 7 is fail. हमारे यहाँ पे मॉड्यूल फेल होता है. Now what we can do? There are three options. One, you can increase the module. Second is increase the hardness and change the material. Okay, now we are choosing first one, increase the module. By increasing module to the next, m is equal to 8, calculating the value of a b. Okay, अभी यहाँ पे a का वैल्यू आ रहा है 24.8 and b का वैल्यू आ रहा है 8 centimeter. Putting all the values, what we get? Induced sigma c is equal to 6005. It means still it get fail, मतलब अभी भी ज़्यादा आ रहा है. Again we are modifying the module. Now we are referring the next, m is equal to 10 mm. Okay, so m is equal to 10 mm. The center distance is equal to 10 multiplied by 17 plus 45 by 2, that is 31 centimeter. B is equal to 10 centimeter. Now putting all the values, what we get? Sigma c induced is equal to 4322. Now it is safe. Okay, डिजाइन अपना 5000 है, उससे ये कम आ रहा है. इसका मतलब m is equal to 10, module m is equal to 10 mm is the safest module. Now next we need to check it for static, dynamic and wear load. Okay, so first of all, calculate the dynamic load. We can calculate in two methods. First one, referring PhD page number 8.50, FD is equal to FT multiplied by CV. FT is a transmitted load in kgf. CV is the velocity factor that you can calculate from PhD page number 8.51. So here you can calculate directly Vm, small Vm, that is a velocity factor. V is equal to pi dn by 60, that we know that. Diameter is nothing but module into the number of teeth. So we are calculating all these things for pinion. So Vm is equal to pi dp, that is diameter of pinion, and p number of speed of pinion, that divided by 60. So dp हम लोग कैसे निकालेंगे? As I said, module into number of teeth on pinion. Okay, so putting all the values, what we get? V is equal to 1780.23 millimeter per second. So it is nothing but 17.80 meter per second. So the value of Vm is lies in between 5 to 20 meter per second, where the gears are cut carefully. Okay, so Cv is equal to 6 plus Vm divided by 6. Okay, so putting value of Vm, what you get? Cv is equal to 3.96 meter per second. Now you can calculate the value of Ft. Now P we know that 9.5 into 10 raised to 3 is equal to Ft into Vm. So we can calculate Ft. Ft is equal to 533.7 Newton. We can convert it into kgf, that is 53.37 kgf. Now we are able to find out value of dynamic load. Fd is equal to Ft into Cv, that Fd is equal to 211.34 kgf. Okay, now secondly, you can calculate the dynamic load by using Buckingham's formula. Referring PhD page number 8.51, Fd is equal to Ft plus 0.164 multiplied by capital Vm into Cb plus Ft divided by 0.164 into capital V small m plus suffix m plus 1.485 square root of Cb plus F. Okay, so here the capital V m is having in meter per minute, and we have meter per second, so multiplied by 60, Vm is equal to 1068 meter per minute. Now no unknown value is the value of C, which we can find out from table number 41, PhD page number 8.53. For 20-degree full depth involute profile, or 20-degree full depth pressure angle, and the material which is selected is a steel. The value of C is equal to 11,860 E is nothing but a correction factor error while cutting. That error we can find out from table number 42 on same page. Same page. For module 10, with the value of E is equal to 0.091, which could be a first class commercial gear. Okay, now putting the value of E into the C, what we get? C is equal to 1067.4 Newton mm, that is 106.7 kgf per cm. Okay, so putting all the values, now all the values are known to us. Now put all the values into the equation Fd in a Buckingham's dynamic equation. What we get? Ft is equal to 5765.1 Newton, that is 576.5 kgf. Okay, from both, if you compare the both value, first value is 211, and second value is 576. So we are preferring the greater value. FD is equal to 576.5. Now calculating for wear, the value of wear load should be greater than the value of dynamic load. So FW, referring PHG page number 8.51, FW is equal to dpqkb. dp, we know that module into teeth on pinion, that is 10 multiplied by 17, 170 mm, that is 17 centimeter. Q is equal to 2i divided by I plus minus 1, where I is equal to 2.64 pi. Putting all the values, what we get? Q is equal to 1.45. Now K is the load factor for pinion, referring page number 8.51. K is equal to sigma c square into sine of alpha divided by 1.4 into 1 upon E1 plus E2, 1 upon E2. E का वैल्यू तो हमें ऑलरेडी पता है, Young's modulus for steel, that is 2.15 into 10 raised to 6. Putting the value of sigma c, alpha, E1, E2, what do we get? K, that is load stress factor for pinion. K is equal to 5.68 kgf per centimeter square. Now all the values should put into the equation. FW is equal to 1400.12 kgf, and the FD value is 576.5 kgf. So the value of FW, wear load, is greater, so our condition is satisfied. Next one, checking for static load. Now we have to compare both values with the static, and both should be lesser than the static load. Now using Levis equation in PhD page number 8.50, Fs is equal to sigma b into p into yp into pc. Okay, I have modified the equation which we have already discussed. Fs is equal to sigma b into p into yp into m. So putting the value of bending stress, width, Lewis form factor, and module. Okay, what we get? Fs is equal to 4410 kgf. Now when you compare both values, Fw and Fd, both are lesser than the static load. It means that our design is safe. Now next and last part of the design is to calculate the dimensions of pinion and gear. Okay, as I told you, you can refer PHG and find out the standard dimensions, that is the center distance, tooth depth, pitch diameter, pinion diameter, tip diameter, or draw a gear or pinion assembly diagram, and using that empirical relations you can find out the values. Okay, so this is the simplest way we can design the two-stage gearbox. Okay, if you have any doubt, you can feel free to ask. You can ask me anytime. I hope everybody is understood. This design process is very simple, and the repetitive task is there. So it is very, if you are doing properly or if you are practicing properly, you can very easily understand and you can properly solve this question. Okay, so thank you very much for joining this. If you have any doubt, you can ask me. Okay, thank you.